Hello students. So this is ROM and RAM design, and so we are going to consider a simple design where we have to design a 86 system with some ROM and RAM. Okay, let's see with we will design 86 system with 32 KB ROM. Okay, using 16 KB chip and 120 KB RAM with 64 KB chip. Okay, so how you can do that? So you must know this first, that for any 8086 system, you have this 1 MB space, and which is utilized using a 20 address line. Okay, and these address line are nothing but A0 to A19. So this 20 address line gives you 1 MB memory space. So starting location, it's 0000 0H and FFF. So there are 5 nibbles. Okay, because this is uh, one nibble is 4-bit, so 4 5s are 20. So that's why we'll find this is 5 nibbles. So this is how many zero? This is not 1 0. This is actually 4 zeros. Okay, because this is written in hexadecimal, so this is 4 zeros in decimal. Okay, and F is nothing but 4 bits, 1 1 1 1. So your ROM space, this is your RAM space. The starting address is given to a RAM space, whereas the final address are given to ROM space. So this you must know. Okay. So let's understand how to find out the starting address of ROM chip. Okay, because you have to consider from the final address location FFFF, we have to go backwards. So if it says 32 KB ROM, so what you mean by 32 KB? So if you have this 32 KB, how many address line you will require? So for 32 KB, you will require, so this is nothing but 32 into 1 KB. This is 2 raised to 5, and 1 KB is nothing but 2 raised to 10. So this is 2 raised to 10. So you'll require 15 address line. Okay, so 15 address line. So if you consider 2 raised to 15, this will give you uh, the final address as 7FFF for 32 KB. So how do you determine this? So let's see A19 to A15, the uppermost nibble, A19, A18, A17, A16. Okay, so A16, the upper 4 nibble. Then you have this A15, 14, 13, 12. So this is your next nibble. And then you have this A11 to um, A10, A9, A8. And then you have this A7 to A4, and then you have this A3 to A1. Okay, so these are 5 nibbles. Okay, so this. So the starting address in case of RAM, it would be 000. The final address, if you consider 32 KB, 32 KB will require 15 address lines. So 15 address line means A0 to, so this is A3, A2, A3 to A0. So A3 to A0. So for 32 KB, there will be address line used would be A0 to A14. Okay, means A12, A13, A14. Okay, so I will rewrite this again. A19 to A15 would be the uppermost nibble, and A19 to A16, sorry. And after that, it is, let's see, this would be A19 to A16, then A15. I will write this complete nibble A14 because I will be using only 3 nibbles out of these 4 nibbles. So this would I'll write in shortcut 11 to 8, because the final value would be all 1. Okay, so this would be 11111, all 1, final address F. Uh, this would be F, this would be F. And then as I'm using A0 to A14, sorry, A0 to A14. So the till 14 would be 1. So this, the second last nibble, which is A15 to A12, the till A14 you will have all the memory line as 1. Okay, so this would be 11111. Why we, because why we are doing all 1, because this is the final address in 32 kb. Okay, so we are determining what the 32 kb means. Okay, so this would be 0111, which is 7FFF. So your 32 kb is nothing but the 7FFFF. Okay, so the first memory location in the ROM would be FFFF minus 32 kb, and 32 kb upward. So that is nothing but FFFF minus 7FF. So 32 kb माइनस मुझे करना है, तो मैं 32 kb तो मैं डेसिमल में है, तो उसके लिए मुझे इसको हेक्स में कन्वर्ट करना पड़ेगा. तो वही किया है मैंने, इसको 7FFF जो आया मैंने इसको माइनस कर दिया, तो ये मुझे मिलेगा F8000H. तो मेरा फर्स्ट मेमोरी लोकेशन क्या हो जाएगा, F8000H 32 kb माइनस करने के बाद. सो दिस इज माय फर्स्ट address for a ROM memory chip. So I have this first address as F8000H because I have subtracted 32 kb from FFF and I got the first address. The last address would be this. And you know that for 86 system, you have the concept of memory banking. So this is even address and this is odd address. So if you divide this into two parts, the first would become 16 kb because this is a 32 kb space. If you divide into even and odd, this would be 16 kb, this would be 16 kb. So the last memory address would be FFF, which will fall into odd memory bank, and this would fall into even memory bank. So the last space of even is FFFF. So the one immediate address of FFF is FFFE. So this would be the last memory address of even address. So F8001, F80000 is the first, F8001 is in odd, then F800002, and here it would be F80003. In this way, the even and odd memory address spaces would go to even and odd bank, and this will be 16 kb memory space, and this would be 16 kb memory space. So your 16 kb memory space would look like this: F8000EH, and for odd, this would be F80001H2, FFFFH. This would be another 16 kb space. So this will give you a total 32 kb. Same way for RAM, you can calculate. So this is for ROM, and for RAM design, you have this 128 kb. So similar way we'll go. So 128 into 1 kb. So we will determine how many address lines will require. So this would require 2 raised to 7 is 128, 2 raised to 7. So 17 address lines. So 17 address line will give you how much? So this would be A19 to A0 again, but yeah, you will require A0 to A16. So upper nibble would be A19, 18, 17, 16. Okay, and this would be upper nibble. So this will occupy one nibble of upper nibble, and all would be 1 1. So A15 to 14, 15, 14, 13, 12, and then this would be all ones. A11 to A8, and you will have this A7 to A4, and you have this A3 to A0. So all this would be starting address would be 000. The final address would be all ones. So this would be F, this would be F, this would be F, this is F. Whereas as it is 17 line, I will be using only A0 to A16. So only A16 will go, will become 1, and rest would be A19 would be 0, A18 would be 0, A17 would be 0, A16 would be 1. So this will become 1. So 1 FFFH. So the starting address would be 00000, and the final address would be 1 FFF. So this would be 128 KB. You can determine 64 KB chips location. So this would go into the first even, and the final would be going into odd. So the one immediate to this would be FFE, which would be going into even memory location, and 00001H would be going into odd memory location. So in this way, this will become 64 KB. Automatically, this will fall into 64 KB and 64 KB. So this being 64 KB chip, first chip, and this would be second chip, and these are the address spaces for even and odd memory location. So I hope you understood ROM and RAM designing. So the address spaces required, and then the number of chips you will require, it can be understood from this video. So you can have query after watching this video, I think. But this is very simple. Most of the things are very simple, so I don't think so you will have any query. So in case you have it, you can just contact me.